Okay, so in this section, what we want to look at is what is a matrix. A matrix is just an array of numbers. The easiest way to think about it is kind of similar to binary code, or you can think about it as kind of an Excel spreadsheet. All right, so you're just going to be putting data into a series of columns and rows. Okay, so they've got some different vocabulary here that we need to make sure that we know so that when they talk about these things, we'll know what's happening. Okay, so we talk about a row index and we talk about a column index. What that means is when I look at any matrix, typically you're going to use a capital letter to represent a matrix. So let's say that this matrix here we want to call capital A. Sometimes they'll put the box around it, sometimes they won't. So they could call it either of these things. Okay. And when we look at a matrix, we're going to describe it by the number of rows, by columns that matrix has. So if I saw a matrix, say a 3 by 5, what that would mean is I would have 3 rows in that matrix and 5 columns. So it kind of gives you an idea of how you could go draw that matrix just by the name. We call this the dimensions. Okay. Inside of here, so let's say we had this 3 rows, 1, 2, 3 rows, and 5 columns. Okay, so that would be our matrix A here. So I've got 3 rows across, 5 columns down, and anything that goes inside of one of these blanks is going to be what we call an entry. Okay, so that's kind of just how we would read one of these matrices. Okay, so if I had something and I say, okay, well, I want A3, 1. What that really means is I want the row 3, column 1. I want this entry right here because it's in row 3 and column 1. Okay, so you can kind of see how you could identify those different values inside the matrix. Okay, so then we have something that we get into called an augmented matrix. An augmented matrix is really kind of our application to why we're even looking at matrices. Remember when we looked at being able to solve a system of equations, we can do that with an augmented matrix. The reason that we want to look at this is because what we looked at so far is we've been able to solve 2 variables with 2 equations, 3 variables with 3 equations. But let's say that I had 9 equations and 10 variables, right? Some kind of really large number. Although it's possible to do using, our methods that we've done before, it's a little bit more manageable in a matrix form. Okay, because you can also look at a matrix being plugged into a kind of computer and something that it can kind of take all the numbers, convert it to binary code, and we'll look at the application of that in a little bit. And then it'll export our answers. Okay, so this whole idea of getting it into a matrix, we really want to look at that so we can deal with things that are a little bit larger than what we can handle. Okay, so let's look at just the basics of an augmented matrix. An augmented matrix is just going to give us basically a matrix where if I were to just draw it on top of this first example, I'm going to draw a matrix. A line will go through the equal sign. I would underline just the numbers here. All right, and that's what an augmented matrix would look like. So I lose the variables, I lose the equal sign. So if I were writing this, I could have my matrix as 0.01, 0.13, negative 0.03, 0.10, draw my line for my equal sign, 0.06, 0.20. And that would be our augmented matrix, right? So all we're basically doing is we are losing the variables, losing the equal sign, and now we've got the same representation, okay? So let's look at the next one. I want to do the same thing here. I'm going to augment my matrix. Now, I notice that I have 3 variables, and 3 equations. So I'm going to have 3 rows. My rows are going to represent my equations. Okay. And my columns are going to represent my variables. Okay. So I look here, I've got if there's no number in front, I've got a 1 here. I've got a negative 1 for my y. I've got a 1 for my z. I've got a line for that equal sign, and then I'm going to put my 10. Okay, looking at the next equation, I want to line the x's up, right? So this first column represents my x's. So even though they don't line up in the equation, I know that I have to put that 3 underneath the other x. I'm going to have a 3 for my y. I do not have a z, so I will put a 0 to hold the spot. My equals is that line, and then I'll put a 5 there. Now I'm going to move to my third equation. I'm going to have a 1 in front. I'm going to have a 1 in front. I'm going to have a 2, and it's equal to 2. So that would look like my augmented matrix. Okay, so I want to line up all the variables, but I don't actually write the variables. If there's a letter but no number in front, it's a 1. If there's no letter at all, no variable at all, that's when I use the 0. Okay, now I can also go backwards. Say, for example, I'm looking at a matrix and I want to say, okay, well, let's write that as an equation. Not always do I want it into a matrix. Sometimes I want to have it into an equation so that I can solve it. All right, so now we're just going to go backwards, and you can literally pick any letters that you want. Typically, they just use X, Y, and Z, things like that. But you could use whatever letters that you want. Okay, so looking at this first one, I know that I have 2 columns, so I'm going to have 2 variables. All right, I have 2 rows, so I'm going to have 2 equations. And then where this line is going to be my equals. So let's see if we can do this. I'm going to have a 5. I'm just going to use the variables x and y. So I'm going to have 5x plus 2y equals 13. Then I'm going to have a negative 3x plus, I don't need to put the 1, but I could, plus y equals negative 10. All right, let's look at this next one. This time I'm going to have 3 variables, so I'm going to use the variables. I'm going to use the variables x, y, and z. Okay, then I have 3 equations. So starting with my first equation, I'm going to have 3x minus y minus z equals 7. Then I'm going to have 2x. I don't have a y. I'd have a plus 2z equals 8. Then I'm going to have no x, so I just have y plus z equals 0. All right, so it's important, if I'm missing the letter or variable, I do not need to put a 0 in there. But if I'm missing the equals, okay, I do need to go ahead and use that 0 for the equals there, like I did. All right, so now we have looked at what is a matrix, how can I write a matrix from an equation, how can I write an equation from a matrix. Now, sometimes we look at this and for whatever reason it is, we do not want to include what the equation is equal to. So in that sense, we call it a coefficient matrix. Augmented matrix means that I'm going to draw that line and I'm going to include the equals. Coefficient means I'm basically going to get rid of the stuff on the equal sign. And so in this case, I would just be using the coefficients or the numbers in front of my variables. Okay, so coefficient matrix is just one other way to represent an augmented matrix. I just am not using the equals, right? So pretty simple here. So I'd have a 2 for my x, a 3 for my y, a -4 for my z. Remember, I'm not going to use that equal sign. So moving to my next equation, I'm going to have a 1 for my x. I notice that there is no y, right? So it jumps from my x to my z. So I'm going to put a 0 for the y. I'm a -5 for the z. So even though this 2 here is inside here, it really would have been moved over because it has no variable. So I am not going to use that because it is not a coefficient of a variable. Okay, moving to my next equation, I'm going to have a 1 for my x, a 2 for my y, and a -3 for my z. So that's what a coefficient matrix would look like. Okay, so the last thing that we want to look at when we talk about kind of matrix basics is we want to look at row operations. Okay, so what can we do to a matrix without actually solving it? Okay, so what I could do with a matrix, now we notice most of the time there'll be augmented matrices that we're going to look at, but they could be a coefficient matrix. But I'm going to look at 3 row operations. Okay, so within the matrix, what could we do to manipulate those entries? That's what we want to look at. So row operations. I'm going to look at being able to interchange 2 rows. Okay, so the notation that they typically use for that, they'd have a row and then they'd have kind of like a double arrow. And so what it means is I'm going to switch row 1 with row 2. Okay. Then I could replace a row by multiplying that row. So we call that a scalar multiple. So what that might look like is, say, 4 row 1. What that means is that I'm going to multiply every entry in row 1 by a 4. Okay. Then I could replace it by the sum, or I could be adding 2 rows together, whether I'm just adding them the way that they already are, or I'm adding it when I've also been multiplied. So one way I could look at that, I could have row 1 plus row 2. Or I could have something where, let's say I multiplied 3 times row 1 plus a -4 times row 2. So I could kind of look at not only adding them, but multiplying before I add them. Okay, so those are all the different row operations that we want to look at. And they're really important when we start to go solve using matrices. Okay, so let's look at our first example here. And I notice there's not a lot of space, so I'll kind of draw where the 2 examples are. So let's look at this first example here. What I want to do is I want to use the operation where row 3 is actually going to equal the sum of row 1 and row 2. All right, so what that means is that row 1, row 2 stay the same, but row 3 is going to get replaced. Okay, and it's going to get replaced with the answers of adding row 1 and row 3. Okay, so let's look at what that might be. Typically what I like to do is the ones that are staying, I go ahead and write those down so I don't accidentally mess them up. So I'm going to go ahead and write down row 1 and row 2 because I'm not changing those in my answer. But what I am going to change is row 3. Okay, so row 3 is now going to be the combination of row 1 plus row 3. So to get my first entry here, I'm going to take row 1 plus row 3. So I'm going to have 1 plus -1 gives me a 0. Then I'm going to have -3 plus 1, which is going to give me a -2. Then I'm going to have row 4 plus, row 1, which is -4, plus 4, which is 0. Then I have -6 plus 6, which is 0. Right? So this would be the answer because I have now replaced row 3 with row 1 plus row 3. Okay. So let's look at our next one. Our next example here, we are now going to leave row 1 and row 3 alone. They're going to stay, but row 2 is going to be replaced. Okay, so I'm going to go ahead and write down row 1, 1, -3, 4, augment in a 3. Then I'm going to replace, then I'm going to keep row 3. So I'm going to have -5, 3, 4, and 6. Okay. Now I'm going to replace by multiplying row 1 by a -3 and adding it to row 2. So I'm going to go ahead and multiply by a -3 here. So that's going to give me -3, +9, -12, and -9. Okay, that is now what's going to get, so I'm going to scratch this out because I'm not going to use it anymore. I'm going to use my -3 times row 1 to now add it to row 2. So I have -3 plus 3 is going to now give me 0. 9 plus -5 is going to give me 4. -12 plus 6 is going to give me -6. And -9 plus 6, sorry, I wrote all over that, is going to give me -3. Right? So, like in this one, we were able to not only add to, but we used that idea of a scalar multiple. Okay? And that would be my solution. So not only can we write equations into augmented matrices, we can then manipulate the entries of the matrix so that we have not only an augmented matrix, but an augmented matrix with row operations.